Hey everybody, Mr. Bennett back here with set 4 of the notes. We've done a few labs, we've done a lot of practice problems. Now we're going to kind of get momentum down into that knowledge level idea. So this is the basic intro stuff that relates to all the things we've been doing in class, so we have it all in one place. Remember, velocity, we've talked about this in class, is a speed with direction. It's a vector quantity. D-I-R-E-C-T-I-O-N, direction. It's a vector quantity. We have an amount in a specific direction. That direction doesn't matter as long as we describe the direction. So while they're not the same, speed and velocity are related to one another. Okay? Speed is scalar, vector for velocity. The v's go together, and the s's go together. Look at that. All moving objects have momentum. This is a quantity that describes some energy carried by a moving object. So right now I'm moving my hands around, there's momentum there. If you throw a ball, there's momentum there. We're going to give you a definition down here in just a minute. The equation you need to know is P equals mv. P is momentum. Alright, so P is the symbol for momentum. M is your mass. So how heavy is that? How much stuff is there? And V, probably guessed by now, is velocity. Okay, and for your units here, remember mass is given in something like kilograms or grams or some standard unit. And velocity is similar to speed, where its unit is meters per second. So our final unit, when we multiply mass times velocity, is you get kilograms times meter over second. Kilogram meters per second. So this is an amount of energy that relates to the amount of mass an object has and its velocity. Nothing cancels out. They're not the same. Momentum expresses the movement of a body, okay, and its resistance to slowing or slowing down. So it can describe the energy it carries as it moves and its resistance to slowing down when it meets another object. So if we look at a couple examples, let's scroll down here. If you have a 60 kilogram halfback, so this is your mass, is moving eastward at 9 meters per second. Here's the velocity. What is the momentum? So this is question mark P. Remember, P equals mass times velocity, and we plug in our variables. So we have P equals 60 kilograms, include your units please, times 9 meters per second. And when you multiply those together, 60 times 9 is 540. There's your quantity. And kilograms, meters, and seconds do not cancel each other out. Kilograms is in a numerator because we can put this whole thing over 1. So we have kilogram, meters, and that little dot just means they're multiplied together per second. So this would be your final answer. This describes the momentum of that person. Example number 2, we can also rearrange our equation and solve for missing variables. So what is the mass? So here's your question. What is the mass, question mark, of a person who is walking east? Here's your direction at a speed of 1.1 meters per second. So this is their velocity with a momentum of 50.5. And there's that unit, kilogram meter second. So this is M. So if we have P equals mv, fill in your variables. So our momentum, sorry, not M, it's P here. Your momentum is 50.5 kilogram meters per second equals the mass. That's their question. So x times 1.1 meters per second. And this is your basic algebra. So we divide this side by 1.1 meters per second. This is divided by 1.1 meters per second. And notice your units. This is exactly the same, so that cancels. I have meters on top on both, so those cancel, and seconds on bottom for both. So our final unit is going to be kilos, and we do 50.5 divided by 1.1, so 50.5 divided by 1.1, and that gives us 45, and you get this big long repeating decimal. Give me one decimal place. So the mass of this person is 45.9 kilograms. Okay, so just like your speed equation, you can rearrange to solve for missing variables. Momentum, this is another property, must be constant after a collision. And if mass cannot change, typically mass does not change. Now if you hit hard enough, you know, you'll add some mass because they'll fuse, but we're not going to get into that. Difference is usually shown in velocity. And you can see this if you do a simple demo. We're going to take a look at this in class, but what you can do is you can drop a ball with a smaller one on top, watch how the velocity changes if those momentums have to stay consistent. I've got one critical thinking question here for you. If you want to change momentum, what can you do? So take a look at that. We will take a look at these in class. We're going to do another lab and a demo, so you'll see a lot of this, but please make sure you take a look at these CTQs because they will help you form understanding.